Most welcome.
Introducing Kelvin Hill from Uscribe. Kelvin's had 5 years experience in the laser field, with a lot more experience in technology prior to that. So he brings to the table some incredible wealth of knowledge on the hands-on aspects of lasers, along with projects and the challenges faced by educators on a daily basis. Over to you, Kelvin.
Thank you, Jay. No, that's good. I guess we can all relate to what the theme of the session, and that is to engage the students. Remember well my years at school where you did tech drawing or GD&P or whatever it was called. You could draw something, but you never could see whether it was actually going to work. Well, what I've been excited about in where I've been now, what we're doing in work is how laser technology immensely helps with that connection. Always the challenge to whether what you actually draw will actually work, and so I've proved it many times over and over in the last few years. Lasers have become indispensable. Early days it was a novelty. Just the 1 or 2 schools in the city would have a laser, but now they're becoming the go-to. Not only in design, but so many other subjects are finding the benefits. We've got textile departments. We've got even the catering subjects using lasers in some schools. But what's become, I guess, what's helped this evolution is the lasers themselves, and we'll see shortly. But they've become so much easier to use. The software has become more user friendly. So what we're seeing now is students in the primary years. Lasers have gone from machines that were strictly for industrial applications. Then we saw the higher grades using them, years 11 and 12. But now that's coming right back, and what we're seeing now is coming down into even the primary years. They become easy to use, and so it's very easy for the teachers to engage the students with a laser. Seeing also where it's almost an expectation. Parents are looking. We've seen for schools that are on the leading edge with technology and this sort of thing. So yeah, it's just time and time again. Teachers tell me about the excitement of the students. Here's a machine. It's very safe machine. Gives them the concept of CNC machines without the moving parts that you might see on a router. Benefits of, as I've mentioned earlier, can their design actually be assembled? I know I've proved it myself, come up with a wonderful design, but find that once you've cut it out, you can't even get the thing to go together. So they're real life experiences that the students can get from these machines, which is so exciting, and it doesn't cost a lot. Some of our schools are just using basic material like cardstock, doing prototyping with cardboard. So it doesn't need to be expensive. And yeah, as I might have mentioned there on the slide, just the characteristics of different timbers. Laser, of course, uses heat. The working medium is heat, focused heat, and then so you get to see that. You see what the different characteristics are of different plastics and timbers and the like. So yeah, when it comes to what you can do, well, what can't you do? There's been pictures popping up there, but from the most basic box, you can do leather, your leather work. We had some students turn out some beautiful, one young lady in New South Wales did a whole bridle and saddle set for a horse, you know, with the embossing of the leather and the cutting of the leather. So literally the limitation is the imagination of the student. It's exciting because of that. And we've touched on it briefly, but yes, whether it's timber or paper, acrylic, leather, full range of fabrics, denim. Some schools do a lot of engraving on denim. It comes out really very nicely. Cardboard, you can do your rubber stamps. You know, the question is, where do we start? I mean, it's the scope is so huge with a laser, and they're fast as well. The advantage of a laser over a 3D printer, for example, is speed. Every student can do their own project, whereas 3D printers tend to be one project per group or one project per class because of the restrictions of the machinery. And when it comes, what I mentioned at the beginning, when it comes with the software, the control of these machines is becoming easier and easier. Got some basic programs which Sam's going to show us shortly, where from, you know, basic text and the importing of clip art and symbols. Wonderful new innovation where the student can do some freehand drawing. The machine will scan that drawing and then produce it into a result with an engrave or a cut. And then right through, so as the student progresses, you can introduce more standard design and CAD drawing software, and then you can print or laser direct from that software. So the laser is wonderful invention, covering a wide, huge range of possibilities when it comes to projects, huge range of possibilities when it comes to materials, and the user friendliness that covers almost I don't know what year you could start at. That'd be up to the teacher, but it's so exciting to see the excitement on the children's faces when something's made, when something's produced. But what I think we need to do is hand it across to Sam, because Sam will be able to give us the real deal. That's which everybody will be waiting for, I'm sure, is to see how these things work. How about that, Sam? You'll be able to take it on from there, do you reckon?
Thanks very much, Kel. Some awesome insights and ideas you've given us. So today, as Kelvin said, we're going to be doing a demo on the GCC E200, which I have here behind me. And we're going to be cutting out a little cube like this out of balsa wood. So as Kelvin's touched on, we can use lasers to enhance engagement with your laser. So today, to be able to enhance engagement of students, we're going to be using several different programs. So what I'll do now, I'll just share my screen. So some programs that you can use is your standard drawing programs such as Illustrator, Corel Draw, there's many other ones like that. And then there's a Smart Job program, which you can see here on the screen. And there's also the Smart Cam. There's many other different options we've got. Now, I'm just going to quickly, you'll notice I've shared the screen there. So for better viewing, if you just go to the top right-hand corner of the screen and then drop that down and just click on side-by-side speaker, just for better viewing there. Now, on the screen, we've got the Smart Job application, which is a program that comes with the E200. Now, Smart Job integrates with the drawing programs such as Illustrator, Corel Draw, whatever other programs you'd be using. So I'll just give you a quick demo now on how to use Smart Job and how we can integrate it with Illustrator. So Earlier I've drawn up a this box in Illustrator. So what I'm going to do now, I'm going to import that file into SmartJob. So we just go up the top of the screen here to import, and then I'll save this file onto my desktop. Just click on that and then bring it into our SmartJob program. So as you can see there, you can move it around wherever you need to on your laser bed. Just going to pop it up in the top corner. Now, I'm going to give you a quick demo on the smart cam on these lasers. So the camera's obviously at the top here with the lid. So just going to pop our laser material in here. Now, so just to increase student engagement, we can not only using drawings and whatever on the computers, we can also use the smart cam to draw and do so it can incorporate all ages. We can do a simple drawing like I'm going to do here today. I'm going to draw a little stick figure, and you can even go right down to a really detailed graphic drawing. So just going to draw a quick stick figure. You got to see that on the camera there. Now, what I'm going to do, I'm going to pop that stick figure inside on the laser bed here. And then what I want to do is take a photo of our laser bed. So up the top here, just click on capture. Now, as I said before, today we're only doing a very quick sketch, which we can obviously do very detailed drawings, so it incorporates all ages and which creates greater engagement with students. So on the screen there, you'll notice we've now got the picture that I've drawn. So we're going to trace the little stick figure that I've drawn. You can also see at the back here, we've got the balsa wood that I popped in there. We just go up to trace up the top here. And then we're going to trace the background that we've taken our photo of. And then that will pop into the little screen over here. Now I'm just going to crop that down because I only want to be able to trace the little stick figure that I've drawn. So just crop it down to there. And then I can zoom this up so we can obviously see a bit better. And then obviously over here, then we fiddle with the settings and we change it till we have a nice contrast here so we can see the green section. Once we're happy with that, then we hit OK. And then you will notice over the side here, we can then move our little stick figure around. Now, when I pop this on my little box that I'm going to cut out, notice that it's slightly bigger than the top of the lid. So I can resize that and just change the size of the stick figure, center it on my job. And so once I'm happy there, we can then change our settings of the laser. So obviously with the box, I'll want to be able to do a cut. So just clicking on cutting data there. Now I want to slow the laser down a bit. I have good power. I'm happy with that. And then I want to change our trace to just a lighting grey. So we want to do it nice and fast. And then we're going to turn our power down a bit. Okay. So once we're happy with all that, and over the side here, you'll see print. We just click on print. And then that will send it to our laser cutting machine. Righto. So over at our cutting machine, you're going to see on our touch panel, you can see that the drawing has dropped into the laser. So all we do is just hit start. Away it goes. So now we've run through that, you can see how simple it is to use the E200. And earlier we talked about the smart camera, and we mentioned how we can use text. Obviously, I've only done a small drawing, but we had an example a few weeks back. It was obviously Father's Day, and we had a few teachers sending us photos of what their students had done with their lasers. One of the examples was a student had written a handwritten message to their father, and they engraved it onto a keyring. Just a good little way to enhance our student engagement. Another way to use lasers to enhance student engagement is using multiple different materials. So you can obviously get a range of different acrylics, timbers, and joining them in, making one project out of multiple materials. So I've got an example here that we did. It's just a simple clock, but it's using two different colours of acrylic, which gives it a great contrast and makes it really interesting. You can see there it's nearly finished our stick figure. So now it's finished the tracing. Now it will move to the cutting. Now, obviously, I've used balsa wood today because it's nice and quick and easy to cut out. On this machine, you can use multiple materials, acrylics, hardwoods, many different things you can use on it. Another great, the lasers are also good in a classroom. I think Calvin might have touched on it. One really good benefit of it is the speed that they can do things. So this program will take about 2 minutes roughly. Whereas if you use other technologies such as 3D printing, it can take a good few hours with one project to finish. So it's nearly done here. It's getting out its last little box. But yeah, so that's completed. As you can see, you can just pop it straight out. Creates a brilliant cut. Now, here you can see we've got a really nice engrave. Should be able to see it on the camera, hopefully. And it's done a really nice cut. And then the picture that I drew, it's traced that on there perfectly. So that's just a quick demo on what you can do with these machines. Jerry, I'll hand it back to you and open it up for some questions.
Well done, Sam. Brilliant presentation. It really shows what you can do. Some new technology that's come out into the market in recent months, maybe the last 12 months. No doubt everyone's seen a laser in action or would have a laser, no doubt. We thought we'd just bring some little ideas to this sort of forum, just to get the mind thinking of what more can we do, what more can we be doing to engage our students, to further enhance their engagements level. Is there any questions for Calvin or Sam from our presentation?
What would the cutting thicknesses be for different materials?
Great question. Yeah.
You'd be looking at this little machine's a 40-watt laser. So we typically talk about the machines in. I mean, there's folks out there that will say some pretty what I consider ridiculous capabilities. I always like to look at it as what is something that will cut at a commercially acceptable speed, which means that you can get all the student jobs done quickly. For this little guy, I'd reckon up to 6 mil, preferably 3 or 4 to keep the speed up. So yeah, 3 mil acrylic, 3 mil, 4 mil ply. But yeah, you do up to 6 or even thicker. But of course, what happens with the laser, the thicker you go, the slower the machine has to run. So it is just a situation of balancing the time that you've got available in the session with how many jobs you want to put through.
That's a great question. So a little demonstration there we saw that took 2 minutes approximately, and that's a 6 mil balsa wood. So give you an idea of how quick that took for that size project. A great question. Another question's come through. Can laser cutting be blended with the CodeClicks products? Probably a question there for you, Nick.
Yeah, look, we have blended it with different technology. You saw some of the 3D printing stuff we've done. We've also, built this little project where, these are laser cut grippers, and it's got the ultrasonic sensor, and you use it as a bit of a laughing robot. As you go up to it, the hand tries to grab you. So, you can build all sorts of structures quite quickly. As Kelvin said, the beauty of the laser is its speed. So whether you're building a bridge or a grappling hook or something like this, which is a 4 degree of freedom sort of, robotic arm, you can actually automate it very quickly because they're light materials. So acrylic doesn't weigh much, balsa wood doesn't weigh much. So you don't need big heavy motors, just little servos and low current that the CodeClick system can control and operate. So good integration, good engagement.
That's excellent. That's a very good question there. Any further questions? Last 3 minutes of the session.
So Kelvin, I had a question about that particular laser. I've got a fairly clunky one here, but are there cheat sheets supplied? So, with the different materials, what sort of feed speeds you need to use, what sort of settings in terms of, power and things like that?
Yeah, absolutely, Nick. That's one thing we provide for all our schools, cheat sheet to get them started. It is important to get kicked off. But yeah, no, absolutely. We provide pretty much all the resources that's needed and the ongoing support. Yep.
Just another thing on that, Kel. On the Smart Job program, I'll just quickly share my screen. So over the side here, it's got the material parameters. So you can click on that, and then you can select what material you're using. So say you're using 2 mil acrylic, you can click on that, and then it'll automatically bring in your speed and power, recommended speed and power.
Yeah, that's good. Thanks, Sam. And as you can see there on Sam's screen, you can actually add your own. It comes with presets, but you can actually add your own materials as you find other material to work with. Yep.
Yeah, That's certainly a bonus feature over the clunky one I've got, where you got to, lose a lot of material just trying to work out what's the right settings. So certainly a bit of an efficiency.
It's good. Another question's just come in. What is the approximate cost for the laser cutter shown? Calvin, you could answer that one for us.
Yeah, I'll give you approximate. Sorry, I should be more up to speed with the latest. But it's looking between 10 and 11,000 plus GST for that machine. That's all inclusive. Comes with an oil-free compressor. And a water chiller because they're a glass tube. They're a glass tube laser. So yeah, that's all included, and the software is all included as with the smart job that Sam's been showing us is included. So yes, there's everything included to get you up and going. On top of the actual laser yourself, that as well, you would need an extraction unit, which you could discuss that with one of the salesmen. There's a couple of different options there. But yeah, extraction is important with the laser. You've got to get rid of the smoke and the fumes coming off the material that's been processed.
Very good. Questions just come in there. Warranty and tech support. So a word or two on that, Kelvin.
Yeah. Tech warranty. These machines come standard with a 12-month warranty. We do have packages available. We call them care packages. That will there's a bit of a suite of different levels where we can set you up on a program where you're only paying a fixed amount year on year. And yes, tech support. We've got tech support here in Australia. No need to go offshore for that. All your tech support is provided by Australian technicians, which can get to you promptly. Yeah, sorry, Jerry, it's pretty poorly put, but you say.
That's very good. And with these circumstances we're in, we've got technicians in most states. Is that correct? Correct.
Yep. Having said that, this particular brand has been very, very reliable. We haven't had any situations, even with the limitation on movement, with lockdowns and the like. We haven't had any situations in the whole country where anybody's been down. They're extremely reliable from that point of view. Yep.
That's good. Another question. Bit over time, I'm sorry, but is there any other bigger laser options available in this range?
Yeah, absolutely. This one's the baby of the family. There's two in education. There's two sizes above this one. The biggest and most common one has got a 960 by 610 bed size with 100 watts of laser power. And there's one in between. Oh, look at that. There's our operators scrolling around there. That's that machine there that we can see would be the top seller in Australian schools. That's the 960 by 610 bed size. The beauty about the whole range is that the print drivers, the software that drives these machines, is uniform across the range. The smart job is unique to the E200 that Sam's shown us, but the E200 has also got a standard print driver, which is then the use of that is common across the whole range. So if a student's introduced to the little machine, well, they're automatically familiar with the larger ones.
That's very good. Well, that concludes our first virtual expo. Thank you very much for joining. We really appreciate you coming on board. There will be an email sent out tomorrow with a survey. We'd appreciate your feedback on how you thought these went, whether we can improve them, how we can improve them, and what you'd like to see. If there's any other content you want to see in future expos moving forward. It's really just it's on us, I guess, to bring to the market what is happening in the environment. We can't see each other like we used to. Maybe those times will come back. But I guess you'd like to, if there's anything you'd like to see, let us know in the feedback form. We also have these machines. If anyone is interested in seeing a virtual demonstration of any of these machines, we've got this showroom set up as a virtual showroom. So you're free to yell out, send us an email, give us a call. I'm more than happy to send you through a quick demonstration of how these machines work. So again, thank you all for the, thank you to Kelvin and to Nick for coming on board as the guest speakers. And more importantly, thank you for the teachers that have spared their time to join this afternoon. Very much appreciated. Have a great evening.
Thank you. You're welcome.
Thank you for hosting.
Thank you.